Hello everyone, today let's solve the problem longest regular bracket sequence, right? So this was asked in the Codeforces beta round 5. So yeah, this is rated 1900. This is fine. Yeah, let's try to solve the problem basically. You can just go through the question. It's easier to solve. It's easier to understand, sorry. I'll just summarize the question so that it will be easier for us to solve the problem. Let's see what the question states here. Just give me a second here, 1 second. 1 second. Yeah, so we are given a string, this one, opening braces, this one, right? So we are given a string, opening parenthesis, also the closing parenthesis, right? So length, whose length is less than or equal to 10 to the power of 6. Just remember this. And we have to find the length of the, what we need to find here? We need to find the length of the, this one, longest substring. Length of the longest substring. I'll just write here ls. We have to find the length of the longest substring, that is regular bracket sequence, and how many such substrings are there. And along with the length of the longest substring, we have to find how many such, this one, longest substring exist. How many, I'll just write here, how many longest substring exist basically, right? That one also we need to find. Just keep this in mind. So this is easy question, right? So this itself, basically if none exist, then we have to print -1. This is also one criteria, right? So this one we shouldn't forget, right? If none of them exist, then we have to print 0 1, right? So this is about the question basically, right? So let me read out the question loud again. Just remember this, listen to this, sorry. So we have been given a string, opening parenthesis and the closing parenthesis basically, right? Whose length is less than or equal to 10 to the power of 6 basically. We have to find the longest substring. See here, we have to find the length of the longest substring, that is regular bracket sequence, and how many such longest substrings are there, right? So that's what we need to find here. If none exists, then we have to print 0 and 1. Very simple one, right? So let's come to the input output. See here, we have been given bracket sequence here, right? And the output here, see, the longest, this one, the length of the longest substring is 6, and such longest substring existing here for this particular input is 2 basically. The same goes with the input or the example 2 as well, right? So here none of them exist, so we have to print 0 1 as per the question, right? So this is fine, I believe. So this is it for the question and the input output part basically, right? So let's do one thing. Let's quickly discuss the complexities followed by the approach followed by the complexities, and then let's write the code. As usual, let's discuss the approach. So here I have considered the same first example that they have given in the question, right? So the output that we need to get here is the maximum, this one, the longest subsequence is 6, and such this one substring that exists is 2 basically, right? So within this one, this one input basically, right? So one thing that we need to understand here is we'll be going with a dynamic programming to solve this particular problem, right? So DP. So let's move on with the step-by-step explanation. So first thing is I'll be considering, or I'll be speaking with accordingly with the same example, right? So just remember this one. So first thing is we'll keep a dp of I. Dp of I is nothing but the length of the longest valid regular bracket substring, that is ending at the index I, right? So dp of I is nothing but, we'll be keeping dp of I, which is equivalent to the length of the longest valid, nothing but regular bracket substring that is ending at the index I. Fine. Now when s of I equals the closing parenthesis, this is nothing but the closing parenthesis, we try to match it with the opening parenthesis. When string of I or s of I is closing parenthesis, then we will try to match this one with the opening parenthesis at the index j equals I minus dp of I minus 1 minus 1, right? Just remember this one, this is important. If j is greater than or equal to 0 and s of j is equivalent to the opening parenthesis, then we extend the previous valid block, right, just before that opening parenthesis to join the sequences. So we'll be going with this one, dp of I equals the previous one, dp of I minus 1 plus 2, plus if j is greater than 0, then we'll display dp of j minus 1, else we'll be going with a 0, right? So just remember this one, So just try to remember this one, right? So we'll be implementing the same thing in the form of code later, right? Let's consider the example. We have considered the same input, right? The first example that they have given in the question basically. So this consists of from 0 to this one 13, I believe 13 is the last index. Total 14 this one are there, parentheses are there, opening and closing, right? So from indices 0 to 13, the key DP updates here are, so I have not considered 0 1 2 3, there is nothing to show, so we are considering the brackets, right? So the valid ones basically. So when I equals 4, iteration 4, so DP of 4 equals to 2, because see, we have found here the valid bracket, right? For the closing bracket, this one closing bracket, we have found the valid opening bracket here. This is fine. For I equals 5, DP of 5 equals 4, because see, here we have already found this one and we have found this one as well. One more this one. For the closing bracket, this one we have found the opening bracket, this one. So we have got 4 totally here, right? So we have got 4 totally here, 4 brackets. Longest subsequence is 4 for now. When iteration is 6, when I equals 6, during the 6th iteration, sorry, DP of 6 equals 5 here. DP of 6 equals basically 5. Just give me a second here. Yeah, so this one DP of 6 equals 6, not 5. So 2 brackets will, I don't know why I have written 5 here. This is nothing but 6. See here, we have got this one 2. Previously we have already got 4, and one more, for the one more closing bracket we have got one more opening bracket. This is 6 basically. Length you can count here 2, 4 and finally 6, right? So this one, the maximum, this one. Longest substring subsequence that we got here is, longest substring that we got here is 6 basically. Count, I am saying, right? So this one, longest substring is 6, and count here is, we will be getting 2, I believe, right? So max we have found here is 6 basically, right? This is fine. Later during the iteration 10, iteration 12 and iteration 13, so DP of 10 equals 2, it will be 4, DP of 12 equals 4 and DP of 13 equals 6. So the second substring length is also 6, right? So result, longest length is 6 and the count is 2. So this one, 10, 12, 13. So this one count, again we got here this one, right? This is the second one basically. So this is the first one basically, DP of 4, 5, 6. This is the count 1. For iteration 10, 12, 13, this is the count 2 basically, right? So the longest substring that we got here is, longest substring length is nothing but the 6, right? 6. So this one length was 6 basically, that I have already shown, and this one DP of 10, DP of 12, DP of 13, this one will be 6 as well, and the count we got here is 2 basically, the second time, right? So the count is 2 and the longest length is 6 here, right? So the final output is nothing but, we have to go with a length along with its count, space along with its count. This is nothing but the space and 2, right? So the final output that we got here is 6 and 2, which is equivalent to the output that they have shown for the example 1 within the question, this one, right? So this is fine, I believe. So as we are completely familiar with the approach, let's do one thing. Let's quickly discuss the complexities part. So what will be the time complexity here? The time complexity would be big of n. So why it is big of n? Because we'll be scanning the string exactly once and each step does big of 1 work. So overall time complexity would lead to big of n. This is fine. So what would be the space complexity here? The space complexity would be big of n as well, because we'll be making use of the DP array of size n, right, which is the dominant extra space. So overall space complexity would lead to big of n as well. So the time complexity and the space complexity for the code that we'll be writing in the future would be big of n and big of n respectively. Now as we are completely familiar with the approach and the complexities, we are good to write the code. Let's start writing the code. So now let's start writing the code. I'll just come here. First we'll be making use of the fast input and the output. So I'll just this one, import the input output package. So this is fine. Also we'll be making use of the different utilities. I'll just import utility package as well. So this is fine. Now let me go with the class name main. You can just give any class name. I'll just go with the main. That's relevant to the question basically, right? So I'll just go with main method here. Let me remove this one, and also let me include here this one, throws input output exception. So this is fine. Within the main method, let me go with a buffered reader. So this one will be buffered reader br this one new buffered reader new input stream reader. So this one, let me go with system.n. so this is fine. So this is nothing but the fast input reader from a standard input, right? So let's go with the this one output as well, fast output writer to the standard output. I'll just make use of the print writer here. This one, let me go with the out. It's new print writer. So let me give here system.out. Basically this is fine. So the next step would be so we have to read the single input line, the bracket string, this one, right? So we have to read the single input, this one, single input line. So I'll just go with here string s equals buffered reader dot I'll just go with read line here. This is fine, man. Next we have to go with the length of the string, right? So for that I'll just go with the n. Let me assign the n to, or let me initialize n to s dot length. So we'll be making use of it within the code further in the code basically. So as I've said, we'll be going with a DP, right? So we'll be making use of the dynamic programming. So here DP of I is nothing but the length of the longest regular bracket substring, right? So this we know, that is this one, DP of I. So we'll be initializing this one. We have to initialize the DP array, right? So this is nothing but the DP of I is nothing but the longest regular, this one, bracket substring that is ending at the index I. We have already discussed this one. Also we'll be going with the variables max and count. Max is nothing but the longest length that we find further, and how count is nothing but the how many substrings have this particular length. In our case, for the first example, we have got the count 2 and the longest length, substring length was 6, if you remember, right? So for that, first we have to initialize the DP, right? So this is nothing but the DP array. So let me consider array as well. So this one will be new int of, and also as I've said, we'll be going with the variables max as well as the count. Let me initialize both to 0 initially. This is fine. Now let's iterate from the index 1 to n minus 1, right? So for that I'll just go with the for. So this one will be int I equals 1, I less than n, I plus plus. So this is fine. So within the for loop, let me go with the if condition s dot char at. So this one I if it is equal to the closing bracket, so then what I'll do, let me go with the int. So int j equals I minus dp of this one will be I minus 1 minus 1. This is fine, man. So this is nothing but j is the index of the potential magic, right? So this is nothing but the opening parenthesis for the particular this one, closing parenthesis. We know this one, right? So we have discussed this one already in the approach. So we will skip over the previous valid block of the length dp of I minus 1. So let me consider one more if condition here. If j is greater than or equal to 0, and let me make use of caret here, and char at. So this one j is present actually, which is equivalent to the opening parenthesis. Then if the valid index and the character at j is this one valid parenthesis, then we can form or extend a valid sequence, right? So that's what the question states. So I can just write it in this way: dp of I equals, so this one we have discussed in the approach, dp of I minus 1 plus 2 plus this one. If j is greater than 0, then let me display dp of j minus 1, right? Else will be displaying 0. This is fine. Now let's do one thing. Let's go with the if condition here. When we find the new longer max, then we have to update the maximum length. Also we have to reset the count to 1 for this particular new max that we have found, right? Else we have to keep the same, or we'll be going with the same as current maximum. Also we'll be incrementing the count if we have found this one count basically, right? So that's what we need to do. Let me write the same thing in the form of code. If dp of I if it is greater than max, then max, let me assign this one to the dp of I count, let me assign this one to 1, else if dp of I, if it is equivalent to the max, then what we'll do, let me increase the count here. This is fine, let me increase the count. So this is fine, let me come out of this one entirely. So next what I'll do, let me go with a specification. If no valid substrings, then we have to print 0 1, right? So this is fine. If max equals 0, then let me go with output dot println. So this is fine. We have to if no valid substring, then we have to print 0 and 1, right? So accordingly with the question, yeah, I'll just give 0 1 within the strings. This is fine. So we are done with the code. All we have now is, otherwise we have to print the longest length and the count. So I have not written this one at all. So else I'll just go with out dot println. Yeah, so let's add this one thing, maximum length. Also we need space between them, right? So then let me append count as well, right? So this is fine. Finally we are done with the code. We have to flush and close the writer. Either we can go with out dot flush, as we have made use of the variable out for the print writer. I'll just go with the out. I can just make use of flush or close. I'll just go with close. Most of the times I go with the flush. Let me go with the close for this one. This is fine. Yep, we are done with the coding part. So this is it for the code basically. So before trying, before checking the code with the different inputs, so let me copy paste the signature starter template. So I'll just come here, paste this one, let me come to the question. So yeah, let me copy this one. The output that we need to get here is 62. Let's check. So let me run the code. Yeah, we are getting the output 62. Basically this is fine, this works. So let's try the second example, or the second input. We have to get the output 0 1, right? So let's check the same. So yeah, we are getting the 0 1. So the code works absolutely correct. So let me copy this entire code. Let me come here, let me hit the submit button. Let's wait for some time. Yep, let me paste the code here and let me hit the submit button again, right? So I hope this works for all the test cases, man. Let's see. Let's wait for some time. See here. So in the toast it is showing accepted, right? So here I can clearly see the verdict that we got here as accepted. So here we have made use of the pure DP, right? So we have went with a pure DP to solve this particular problem, right? So I hope the solution part is completely clear, along with the approach and the complexities. For now, this is it. Thanks for watching, guys.